needs. In the session 2, we show some demos, which we already see in the talks on the first and the second day, maybe mainly on the first day. No, this with the fairness score, the OntoCommons ecosystem, OCAS, and the marketplace as demonstration. And in the last session, we have a hands-on session, question and answer session about different important topics discussed before. And I'm very happy to have this program today, and I hope we have an intensive discussion on all these topics. Thank you very much. And the first session is shared by Silvia. I hand over.
Wenn die Quatsche ist schon geteilt.
Thank you.
Nee, wir haben die Quatsche geteilt. Es war diese, das geteilt wird. So, do you need this?
Already? Just a couple of words. Do we need to change slides? It's So good morning, everybody. And so my pleasure to introduce the first speaker of today, Hedi, Karray from ENIT, Tarbes in France, who is professor at the École Engineers at the School of Engineers in Tarbes, and is also our technical coordinator in OntoCommons. And he will talk about the roadmap. Then we will have the pitches from the participants, and then an interactive session to gather your input for the project. The floor is yours. Thank you.
Thank you, Silvia. Good morning, everyone. So I tried to summarize the roadmap. I'm sorry, I failed. It was so long. We organized the webinar 1 month ago. It was almost 2 hours webinar. So I tried to summarize from all the presentations of all the chapters of the roadmap. It was really difficult. So I tried to have some focus on some chapters that are related to this workshop. And the amazing thing also is that, let's say, I said, okay, let's follow the hype. I used chat PDF to summarize, and it was totally failed. So I'm happy I'm not alone that failed to summarize, also machine. So what is OntoCommons Roadmap? So it's considering a number of topics that contribute to the ontology commons ecosystem for ontology-based data documentation. So there is 3 main topics regarding this: the ontology foundation, so top reference, mid-level, domain, application, the integrated development environment, so tools and infrastructure, and the industrial impact that includes marketplaces, standardization, education, and human resources. And we designed the structure based on the industrial needs, the state of the art, the gaps from the state of the art, the definition of success, and recommendation actions. So, and this was, I mean, the first version of the roadmap, and the second version will come by the end of the project with more detail and timeline and so on. All right, so the industrial impact. I'll start from this slide regarding that, which is for us, the impact should be the adoption of ontology-based data documentation and knowledge management practices in industry, because it's at a low level, still at a low level, and there is some skepticism regarding ontologies in industry, and this for typical reasons that we will see in the roadmap chapters. And also the impact from the project is really to reach wider adoption regarding ontology tools and infrastructure, and to have usually the human in the loop. This is this is a wish, but it's a must in ontology spectrum, is to have the human on the loop. And so the idea is that industry can expect to reap benefits, including standardized data documentation and fair data, improve communication within company, time and cost saving, increase in innovation capacity, and optimize product quality and environmental footprint while using a data documentation based on ontology. Also, the idea is to have benefit from for individual companies. So the idea is to have this connection, but also for companies is to let's say to have opportunity from this data sharing in industry commons and a system of digital marketplaces that can support needs such as data integration, interoperability, and improve transfer of data between industry and marketplaces. So the roadmap chapters include sections regarding top reference ontology, industrial domain ontologies, ontology commons ecosystem toolkit, infrastructure, industrial applications, standardization, knowledge management, translator for industry commons, ontology-based digital marketplaces cooperation, and innovation and perspectives. So today I will focus only on 3 chapters that I highlighted here. The first one is the domain ontology. So my focus is really to link with this workshop topics. So I try to relate really to the domain and to the exploitation. So as a need, the common need that that is highlighted and we collected from the industrials is that there is a real need for data integration and sharing. So people are convinced that it should be. But even it should be, it's complicated for them to accept and to trust. So this, I mean, we are between, let's say, the must and the trust. Another need, and also we'll see that, and there is some industrial needs in different chapters are common between different areas of exploration in OntoCommons. So there is a real need on standardizations because standards are trusted from industrials. But let's say standards take a lot of time to be adopted. And the industrial timeline sometimes is quick. We want that we adopt, we have POC, we have results, and we need to go to the market. And this is one of the, and especially for SMEs, they haven't time. They haven't a research division that can take time to do stuff. SMEs, I mean, it's something, I mean, amazing, because one time I was in my office, I had a call from a company in Toulouse. They say, yeah, we are interested in OntoCommons and so on. We have, I mean, a project related to ontologies, and we want to go to the market in 6 months. Because we are looking for investment, so we need to have some product in 6 months, and we would like to base it on ontologies. I said, if I'm IT company or consultancy company, I will say, yes, we can do it. But as academic, I will say, no, it's not possible. So there is a real need for standards, but because it's trusted, but there is a problem of the timeline. Also, the domain perspectives, because regarding the domain ontologies, there is different views that can be taken into account when we develop a domain ontologies. In the same domain, there is different perspectives. I'll take the maintenance, that's a domain that I know very well. So there is a lot of ontologies in maintenance, and they are addressed from different point of views. You have the people from predictive maintenance, people from maintenance management, work orders management, others from asset management perspective, others from strategy. And though all those views is not easy to align in one ontology. So there is different perspectives. So when we talk about a domain ontology, there is different perspectives within the same domain. And also there is a problem regarding the interface with ontologies from top level aspect, because it seems very abstract, it comes from philosophy. So people are afraid. So this is bad. They think that there is a need because there is some success stories in the state of the art in some domains. So people would like to have this interface and to bridge this gap with top level ontologies. And then the link between domain experts and ontologies, this is also a need, because industrials say, okay, if I want to do ontology, and you say that it's not easy, it's not only an IT artifact, so we need people that masterize this ontology engineering, not only from IT perspective only, but also from the philosophy of things, what is science, and then also domain experts. So there is a need to bridge between all those different rules. So regarding the state of the art, so we collected almost more than 200 ontologies in different domains. And also we tried to align them and check if they are aligned to top level ontology. As you can see, most of them are not aligned to top level ontologies. And also we tried to calculate their FAIR score, and it was very low. So most of them, they are not aligned to FAIR principles. And also there is a problem for machine readable and not machine readable ontologies. So a lot of ontologies are produced in academia. So they are published in papers, but there is no machine readable versions of those ontologies. Oh, what are the gaps? So there is, we can summarize this regarding the granularity of models. So this related to this perspectives, the lack of generic and application specific ontologies. So there is ontologies, but in very specific domains. So the need to have, there is a gap regarding the, let's say, the mid-level, the core, the domain reference ontology. So there is a lack there. Also, a gap regarding ontology as conceptualization of reality. This is information model or data models. There is a big gap, and it's amazing. It's I was reviewing a paper yesterday, and for me it was a data model, and people say ontology, ontology, ontology. So there is a problem to make this difference and to well show what is the added value from ontology as a formalization of those terms with logics and so on. Another gap is the sustainability. So there is a lot of good quality ontologies, but they are not, they have short life. So they are, let's say, not sustainable. They are not in terms of maintenance, in terms of availability. It's also a problem of funding regarding this, because sometimes we work on the project, we deliver ontology, and there is no funding. A PhD student left, the professor left the university, so it's go to the trash, unfortunately. And also there is a big problem lack regarding the standardized methods for ontology evaluation. Everybody say, yeah, we need high quality ontology and so on. But when people ask how we can evaluate the quality of ontology, and it's the same. There is different perspectives regarding the evaluation. There is the ontologist perspective. There is the domain expert perspective. There is the IT perspective. There is the logical perspective. So it's an ecosystem of perspectives that are in interaction, and we miss really a standardized methodology for that. So regarding all of that, gaps, we addressed some recommended actions regarding the standardization of ontology engineering steps. So ontology is by the end. I mean, this is also an amazing point, because when we develop a product, usually we follow a process, an engineering process, and we are wondering why, when we develop ontologies, people doesn't follow a process. It's an engineering process behind that. So there is a recommendation. I mean, we recommend that we standardize ontology engineering steps. And this is what we are doing with the methodology and the engineering steps in OntoCommons. The alignment of top level and mid-level ontologies and make them accessible for non-ontologist people. So to facilitate this alignment, to have them usable by people who are not specialists for that. Also, the balance of theory and practice is like bridging this gap by saying, okay, there is utility. Don't go to the extremism, because some ontologists, they are extremists in terms of this logic should be like this. There is ontology and not ontologies and all of this stuff behind this. And from the other side, yeah, it's theoretical. We don't need it. The only perspective that they have, it should work. Just told. No, we need to keep a balance between theory and practice. Also, we need to make domain ontologies fair. So the first thing to make them fair is to make them findable and accessible. And then, I mean, try to improve the other aspects of fair by make them interoperable and facilitate their reusability. And one of the let's say, actions to do is to document ontologies. So we are talking about data documentation by ontologies, but also ontologies have to be documented. Related to standards, also we need to link ontology development in domains to existing standards, because it makes ontology more, let's say, easier to be adopted by industrials, because it follows the standard. A standard has some commitment, so ontology should be, let's say, accepted. And this acceptance is based on the agreement. And standards has some agreement in industry, so ontologies should follow that. Another problem that we find also, and we recommend that we have some action on that, is to classify domains. Because when we started to say, okay, let's do a state of the art regarding what exists in terms of domain ontologies, first think, okay, what are the domains that we will focus on? And it was really a problem for us, because there is overlap between domains, there is different categories of domains, and there is some, we based our state of the art regarding domain classification from the European, and then there is a standard from Germany. So we tried to check and to align, but it's important to classify domains in manufacturing and materials, because there is also some classifications regarding education, which is not the same from industry perspective. So there is a work to do on that, and also bridging the gap. So this is why we recommend to support education, training, and why that we are also supporting the translator role in terms of knowledge management, and have this support to the different stakeholders in ontology development. So this is from the domain perspective scope, and now for the industrial application. And I really like this chapter because it's related to our use cases. So all what you will see here is coming from the use cases analysis, not only the state of the art. In terms of needs, so what's also interesting is to classify the needs and the gaps and the actions regarding different aspects. So people, data, process, and that's the three aspects that we focus on. So from people perspective, so the need is to ease of interoperability and communication between different stakeholders. There is a very famous video on YouTube called The 7 Red Lines. I will invite you to watch this, because this is related to that, because it's really amazing and highlights the problem of interoperability and communication within organizations. So also what industrials needs in terms of people is to use best practices for data model and have best practices for data model governance as well as modeling tools. So there is a need that will come also usually is the need of tools. In terms of data, so there is a need regarding the easy use and understand ontologies, and also improve the reusability and of metadata and processes regarding this. In terms of process, so the need is to have time saving in industrial process because this is an objective in industry, but we'll see later that the gap is also there regarding ontologies and also avoidance of physical testing. So in many industrial process, it's desired to avoid physical testing and to go with simulation, and this is also another need highlighted. In terms of gaps, so there is, for people, there is learning barriers for semantic technology in industry. And let's say this is practically important for bringing non-ontology experts on board. So there is a gap on this, and there is, in terms of even, in universities, there is no programs dedicated, for example, with short classes for industrials and so on. There is also high costs of ontology development. And this is also a debate between ontologists and industrials. Say, yeah, it's costly, it took time. So, but this, we say, when you do other stuff, it's also costly. Why? When it comes to ontology, you say it's costly. All your other stuff are costly. All your other stuff take time. It's an engineering process, so it should take time. It will be costly. Ontology are difficult to maintain. Also, this is another gap. And as I said, if people left and ontology is not well documented, so there is a gap on the maintenance, and the gap also is the interaction between internal and external partners in the company. From data perspective, so the gap, as I said, is the documentation of the ontologies, the lack regarding the domains. So as I said, there is a problem regarding standardizing the domains classification. From data also, the arguments for using FAIR principles. That's what, yesterday we had a long day regarding fairness, because this is a big gap between what is done in academia and research and in foundation association standardization and the practice in industry. So there is a problem of acceptance, the arguments, what is the return of investment on that. So there is a gap, and there is a work to do regarding awareness and to well explain the importance of that. The IPR also is another gap regarding the protection of the APR, the industrial. They are, let's say, they have some worries regarding this. The other gap that ontology should follow higher level ontology, and this the same, the alignment with top and mid-level. This is a big gap regarding the industrial applications. And another gap from the ontology perspective now is we say it should be, there is a gap, they are not aligned to top level, but even top level ontologies are not interoperable. They are not aligned. This is, this is a loop. Ontology for interoperability, ontologies are not interoperable. Then we say to make ontologies interoperable, we need to make top-level ontologies, to align to top-level ontologies. But the same, top-level ontologies are not aligned. That's like a snake. From a process perspective, so there is a lack of standards and guidelines for ontology engineering also. The user interface regarding tools, it come usually also as a gap from industrials. Most used tool is Protégé, but it's like all of people say, yeah, but it's complicated. It's not, the visualization is missed and so on. And that's amazing because in our, analysis of what exists in terms of state of the art, we asked people, well, what is the most important features you need? And all it was an agreement regarding visualization. Also, tools are not complete in terms of, as I said, in visualization, but also the scalability and the stability of tools. So, the most used software is Protégé as a University of Stanford University product, and they haven't a lot of fun to continue working on that. That's amazing. We had the chance in OntoCommons that we discussed with them, and there is a miss. So that's why people say, yeah, but Protégé, it's not, there is a lot of miss. Yeah, but because it's not a commercial software. Also, there is a lack regarding the collaborative ontology development tools, is how to make existing tools talk to each other, make them interoperable, have like a full process that tools can be integrated. So there is a gap on this part, and also there is a lack of easy use. It's come to the, let's say, to the training for the use of tools, and also how we can have a balance, for example, have some supporting tools from NLP and so on. So this is also one of the lack. All right, definition of success. Maybe I have to skip this because I take a lot of time. Okay, all right. So let's continue focusing on this aspect. So definition of success, how to make it successful. So first thing is to improve communication with company, personal, and with external partners. So there is a role also to take from our side as people working on ontologies. Achieving standardized data documentation. So this is also one of the success, let's say this, to make it successful, we need to achieve that. Time and cost saving. So also it's, let's say it's from ontology perspective, how to make ontology development time and cost saving. We say that the gap is that it's expensive, it takes time. So we need to think regarding optimization of that. Gaining competitive advantage for small and large companies. This is also the use of ontologies should be democratized, and so have access to make, them accessible for SMEs. So I think also there is a role to play there by having those open ontologies shared at the domain level and make, the possibility to develop application ontologies on top of that. Recommended actions. So knowledge engineering education to bridge the gap regarding the different stakeholders. Demonstrate examples on saving time and cost, and this, I think, one of the role that we are, we have in OntoCommons with our 22 demonstrators is really to show that the added value. Networking, so sharing experience, and this is what we are trying to do, and I think we need to continue on this to share experience regarding use of ontology and show the added value. Industrials like to hear from other industrials. Sometimes they trust other industrials more than academia, unfortunately. They don't believe us. That's strange. Highlight advantages of ontology use. It's also regarding showing what are the added values and show concrete improvement on KPIs. And from data perspective, so we need to push regarding data sharing and standardization, and I think for that we need to have an ecosystem also related to the legal aspects, to the technical aspect from data spaces and so on. So, and also that the economy of data should be also highlighted. Demonstration of FAIR benefits, so show what FAIR can do to improve the data sharing and the impact for the company. FAIR principles also for metadata. That's also make ontologies fair and also make the content of the ontology fair. Close cooperation with the communities, FAIR communities and other communities. So this is important. In terms of processes, so follow good ontology development practices and provide comprehensive methodology for tools. So increase user-friendly of tools, support development of collaborative, modular, and open tools for ontology development. This is also another aspect. And I mean, if you compare this chapter with the chapter before, there is a lot of overlap. And I will go quick with the chapter regarding marketplaces. And I always keep this in terms of needs. I mean, user-friendly come again on the table. Also, improving transferring data between industrial marketplaces. Same is interoperability. So the needs are there, they are common. The state of the art, this is state of the art to compare the use of ontology in different marketplaces, and the objective of DOM 4.0, I think, is to really to integrate ontologies in the domain knowledge on the data set representation and on the infrastructure, not be like previous project, is to have this full picture. In terms of gaps, lack of demonstration, it's related to the previous chapter. Communication between top level and real staff. Methodology, tools, standardization. It's, I mean, it's, I liked, I mean, the manner how we present differently, but by the end we have common needs, common gaps, and common recommendation. So demonstration should be well defined from marketplace perspective, developing common global ontology framework for the marketplaces, and establishing a link between marketplaces. Here I try to summarize, so the slides will be available, but all the document is available online. So you go to our website, ontology, OntoCommons.eu, and then you have a roadmap, and we have an open consultation. So we'll invite you to go, to read, and to be active, to be a contributor. So we are looking for your insights regarding needs, gaps, recommendation, and also the suitable timeline for the action identified. So we need that you help us to define the priorities. And also maybe we missed something. So you will help us to do that. So you have the link, and there is a survey for each chapter of the roadmap. So we kindly ask all of you from OntoCommons partners, from industrials, from academia, so all of people interested in ontology or ontology-based applications. So your input is very welcome. Thank you.
For summarizing this large effort of the roadmap. Are there questions from the audience? Do I see questions online? Yes.
I have a further recommendation, action. Hedi, guys like you have to go to industry to make it happen. Otherwise, it will not happen.
Yeah, I mean, this is also a good recommendation. We need help for that. We are trying our best, and we need support from industry, from policymakers, from academia, from SMEs that already involved. So it's a common effort to go to industrials and to push to adoption. So, I mean, we are not alone doing this. That's why in OntoCommons we are collaborating with all the initiatives in standardization, in other ontology initiatives, and we are not doing this only for Europe, but it will be worldwide. And I mean, the link with Industrial Ontologies Foundry is to make this bridge. We collaborate with Brazilians, with people from South America, from Argentina. They are working with us on the domain level aspects. So it's a worldwide effort to push for adoption, but still a lot of work to do. So this is a recommendation, but we need help. I mean, and especially, I mean, let's say policymakers could help us.
So would be an initiative, something like large-scale pilots for ontology engineering help with industry-led and consulted by, supported by guys like you?
Let me give two examples. One of the project partners in OntoCommons is University of Oslo, the Cirrus Center. This initiative and this lab, which is, there is, I mean, a common, let's say, objectives with industry defined and support from industry, and that make happen in oil and gas. So there is a lot of development there. So this ontology adoption is there, and it's collaboration. So there's access on that. I take the example in US, the National Center for Ontological Research. So they got more than 80 million funding on BAFU-based ontologies. So they work easily with industrials, with the US force armies and so on. So we should build initiatives like this. And I mean, within OntoCommons, we discussed why not continuing with an excellence center that adopt OCHES and push and have, let's say, a wide involvement from industry and ask industrials with the academia, with the policymakers, have a structure that push in this way. So I think this is our perspective also, and that's also what we are trying to do at the national level, to have an excellence center that is focusing on those aspects, and also why not to do it on the European level. And I think Bosch, Siemens, Airbus, they will be interested because they are leading on that, and they can bring other big industrials that could help to facilitate, because it will facilitate their work with SMEs. So big industry is working in collaboration with SMEs. They are subcontracting, and so it will facilitate for them their work. So that the adoption of ontologies and SMEs, from my perspective, can come from big companies.
May I ask one question? What would you expect from the Commission to do? Funding?
This is a big question, and believe me, industrials asking me. OntoCommons will stop in few months. What is the continuity? So my answer is industrials, the Commission funding is stopped now. Maybe will accept more to extend the project or to have a call regarding making in practice OCHES. But also in the same time, we are asking from industrials to support us, to have this continuity for OCHES, to make it alive, to go further in our research, and to make it in practice. So yeah, from the Commission, I will ask for more funding.
See, there are more questions. We are a bit short on time, but yes, please.
One comment of that of Laszlo. I think we saw yesterday also particularly presentation from Bosch. My feeling is also from what I see in IOF and in other industries. So industries are not slowly, but more actively, I would say, taking over towards working with this. And I think the big issue of standardization of ontologies will be also taken over by industry. So in my opinion, the role of the Commission in that direction is to support European participants in the standardization efforts. I don't know the instruments, maybe there are, I know that there are some projects specific to standardization where we are connected to that. And I know that there are projects, many projects that they are using ontologies in their cases, etc. But maybe in order to support a little bit more on the commons and its results towards standardization, maybe a continuation, let's say, support action, but more focused than the OntoCommons. This is my feeling.
It's Danny here. I hear my own voice now, so I have a suggestion. There are several areas in which the ontologies will be vital tools in order to save the use of resources and the ability to support circularity and all these things. But those areas are very complex and might not be useful. But one area that can be of great importance is the support for maintenance operations and asset management in companies and organizations. Because it will be limitations when it comes to available resources, metals and such in the future, and energy as well. So what I would suggest is that one eventually tries to create a proposal or a project that integrates all these factors of education, of standardization, of testing, and trying to coordinate or to glue together these different ontologies that are present in industrial production and maintenance that you mentioned. Was you had a fragmentation there. So one can create a kind of a functional context for demonstrating for large corporations, the managements there, because now everything seems to be quite fragmented. So that is what I would recommend that one look into as an approach. Did you hear me?
Now, yes.
Hedi sounded like a Martian earlier in my headset, so I hope I didn't do the same.
Speaking. Sten? Sten, yeah.
Yes, Sten, yeah.
So anyway, Sten, I mean, we'll continue to work together. I mean, anyway, to push on this direction. And as usual, you have great ideas, and I think we'll go further on exploration of that. To also, I mean, to highlight the suggestions and recommendations. Yeah.
Thanks a lot. So we have more questions, but I think we need to move on because we are a bit late. So thanks a lot, Hedi, for this very nice overview. Thanks all the participants, and we keep interacting on this in the following sessions, but we need to move on. So let's thank Hedi again.
Hi, morning everyone, those online and in person. My name is Amit Bhave. I'm from CMCL, and I'm just presenting this showcase, the 5-minute pitch, with the dome hat on, but also the CMCL hat on, just to give some context. Okay, just to put where we are at CMCL, that's based in Cambridge, and CMPG, our German subsidiary. That's some of the way we look at the world. It's a bit Lego-like, so it's modular, so you can go from component level at the bottom. You can have twins for that, models for that, either data-centric, physics-based, doesn't really matter. And then you build on in that modular level to building, street, city, national, countries, world, etc. The center of it is the world avatar. By the way, the world there doesn't mean world as Earth. The world means anything that can be conceptualized. So the vision and the ambition, bold enough, is to build a world model. There are some examples that we have discussed, and a lot of it, each and every example, first of all, uses ontologies, not to those scrupulous standards as Hedi has suggested. So we need to do a lot of work in improving our capability further in that area. But the common thread is ontologies, whether it's regional, so over a part of the country, whether it's looking into a lab for lab automation, looking at molecular structure of materials and cage structures for MOPS, to the environment in Dome, which brings me to the showcase in Dome. Dome 4.0 is a marketplace ecosystem. The problem at hand, this is one of the 9 showcases. And as I mentioned on day 1, the further challenge is how to get new showcases that sort of are born from the merger of the original parent cases. So we are pursuing 11 in short, but this is one of those. The challenge here is for smart cities, but smart cities focused on the port or harbor side. So this could be cities like Mumbai, Singapore, Rotterdam, or it could be Plymouth, for example. And the challenge there is a lot of traffic with ships, different fuels, everything from conventional gas, oil, and diesels to natural gas to now looking at ammonia and hydrogen. So all this can be accounted for. The ships have contribution towards the gas phase and particulate emissions. How do these emissions permeate through the atmosphere? So it's a diffusion problem, then a CFD type problem. And later on, how does it interact with the local architecture, local buildings? So then it becomes an infrastructure problem. So we are covering lots of domains, lots of sectors, covering weather, ships, whether it's container ship, recreational ship, etc., the city local architecture, as well as air quality. Of course, as we have learned over the last almost 2.5 days, is the need for ontologies to have that cross-domain interoperability. The way we do that is just to give an example of the current state. We have agents as part of a knowledge graph, the World of Tar, and we look at the ship data, which is a live location data of the ships. We look at the open weather, so weather as a function of time, and the city GML represents the building architecture in detail, level of detail 2, or level of detail even going up to 3. So you can have literally a virtual sensor put in your window versus a virtual sensor put in some other room at the doorstep. Based on Joanna's questions, or Joanna and Monica's questions, I've put the points on the right. So it's in terms of benefits and gaps, review of existing ontologies. We have reused most of the ontologies that are published in public domain in journal publications in this case. Any missing concepts, unfortunately, has been done manually here for the sake of, I would say, demonstrating progress. The input agents are key because they really update the knowledge graph. Some of the results and future development and challenges. That's the penultimate slide. So it's the steps for future development in use case. So one is post-processing of results and creating vector layers. So how does the knowledge graph then output the updated information to your visualization boards, while accounting for the complexity of the use case? So we started simple with one ship, then multiple ships, and then to combine that with the third-party commercial dispersion calculations. Lessons learned, data sets can be expensive. We tried to do, or I tried to negotiate as much as possible, saying that this is purely for research within low TRLs, etc. I miserably failed, and we had to pay for it. But this data is vital. Second is the software. We started with a commercial software, and yet not entirely sure whether we should go for a commercial third-party software because of the aspects related to openness versus in this case, a free open software, but at the same time, lack of support and lack of documentation. So we are struggling with that as we speak. In terms of challenges, the input and output data, and ultimately demonstrating this is currently running on the CMCL server. We want to get this running through Dome, but that has to go through a lot of development stages. That's it. Everything else in terms of is open in publications, in terms of code, in terms of everything we do for the public funded projects. So feel free to browse that site and otherwise get in touch with me or anyone else from Dome. Thank you.
Yeah, thank you so much for the introduction, and I'm so excited to be here. At the KIT, we've been working on producing fair data, and that has been what we've been focused for the past approximately 3 years. And in that process, we've developed a few software solutions and we've published a few showcases. So I'll use the following 5 minutes to introduce that. So I will switch my pointer on. Yes. So how did we get into this? When I started my postdoc about 4 years ago, I wanted to find a method to transform lab operations in our field to the next generation of research. And by the way, I'm an experimentalist from the lab by education. So all this data landscape was completely new to me. So I thought that we could do better at preserving data, which would accelerate lab operations, and it would enable us to share data without much data wrangling on both ends. And finally, hopefully in the future, be able to run machine learning on actual meaningful data. So it's no surprise we arrived at the fair data principles. I'm not going to convince you that they're a good goal to strive to, but one aspect that I don't see mentioned too often is that fair is actually green, because experiments and simulations alike are very resource intensive, and having to repeat existing experiments that have been performed already is a costly endeavor. So really creating this fair digital object infrastructure is a way to preserve our environment from the R&D operations. Okay, so our specific field is tribology, and we wanted to work on tribological data. And just as an illustration, this is a typical case of tribology where the stone is sliding down the ice, and we work on friction, wear, and lubrication. The deal is that the friction in this case is not a property of the ice or the stone, but actually a property of how the ice was prepared. And that led us to the realization that actually the value of our data is in the preparation steps, not in the experiment itself. The experiment is way down the line. So we asked ourselves, can we redo a tribological experiment fairly? We published 2 publications just last year on showcases how to do that with vocabularies, ontologies, electronic lab notebooks, and publications, and also persistent identifiers. So our current framework that we are working in looks the same. This is a colorful slide, and usually I take about 15 minutes to present just this slide. But what I want to convey here is that our goal is to have all our data on a repository, be it Zenodo or any other repository. We want that data to be annotated, and for that we count on electronic lab notebooks. But to have the schema for annotation, we use the vocabularies that we develop in our home-developed software called VocPopuli, which supplies the schema for metadata collection in electronic lab notebooks. And it also provides a SCOS vocabulary, which then through machine learning we convert to more complex ontologies, which then augment the metadata in the electronic lab notebooks. And last but not least, these vocabularies actually integrate very well with other solutions in the lab that substitute in practice, the paper lab notebook on the bench, or they integrate well with any type of action that an analysis on a computer would require, and we annotate those analyses before we upload them to the electronic lab notebook with the vocabularies developed in VocPopuli. That all we package together and we publish to a repository, and we have showcases of these already done. So with this, I'm going to skip to my acknowledgements, and thank you for your attention.
Thank you, Nick. Thank you. I would invite Martin, please. Martin Horsch, who is a professor at NMBU, Norwegian University for Life Sciences, and visiting scientist at TFC UKRI.
Yeah, no. I'm not going to show the slide because it's technically an internal document and I did not get the approval for that in time. It's also not necessary. Let me just point you to what a use case would be or what the thing is that I would like to show.
Share this one.
I should have taken the other one, right? I'm sorry about that.
Is it okay for you to look here?
We have it. It's the Green Data Lab. All this goes off my time. Okay, let me just talk a bit about Norwegian society. So personally, I'm at NMBU. That's the Norwegian University of Life Sciences. So traditionally, this was the Norwegian College of Agriculture. And if you ask Norwegians what are the important fields of activity, of work, you will figure out, people think of Norway as like a very modern country, but people will think it's first and foremost the oil and agriculture, and then maybe defense in case the Russians attack or, God forbid, Sweden, then to be prepared. And that's something you know from other countries also that are more considered part of the third world. So spend some time in Iraqi Kurdistan, people will say the same thing. The agriculture, the oil, and the defense. And anyway, this is just to say that agriculture has a high standing in Norwegian culture. Every second Norwegian dreams of being some kind of peasant, and engaging in agriculture is very, very present. And here we are now experiencing the data orientation as a very first step going toward this, where all the disjoint use cases that we have in the university and the related institutes are collected, like the digital salmon, gene information about the salmons, agriculture, people taking pictures of fish and trying to analyze and identifying them, or pigs, how are they moving, may they be sick, and so on, very disjoint cases. And we have seen before that also as regards uptake of data technology, there is a huge difference. In one of the previous presentations we saw, for example, biotechnology is very advanced, it's maybe the most advanced field. And on the other hand, food production was very much at the bottom. And so here there's a lot of work to be done and even to understand each other at the very beginning. And I just would like to point you to one event which is going to be held in June at our campus, which is a very nice campus, Green Data Lab Conference. It has its abstract submission deadline. Just have a look at that. You find it through Green Data Lab NO. Abstract submission is very soon. Maybe it's of interest to one or the other. How can we contribute to the common data space in agriculture? What other things might you have to tell us? The head of all this, of the Green Data Lab and of the conference, is Achim Kohler, a colleague. He's a professor of biospectroscopy, and he organizes all this. I would like to tell you one anecdote without giving too much detail. Again, Norwegian society is very structured. All the peasants from the different fields of production, they're highly organized. So they may be in a cooperative, in some other kind of joint organization. All the peasants from the field are organized together. And oftentimes they have very advanced data collections. And now it has happened that one of these organizations is trying to sell their data. They have a spin-off for that. We try to contact them for a project. And the response was, oh no, we're not going to be a partner. If you would like to use our data for your proposal, no, you have to pay us for the data. But maybe they would have reacted differently about an idea such as a data marketplace. That's what they're trying now. So in that respect, it is very advanced, and maybe there's some promising contacts to be made in the future. And that's what I have to say.
Okay, so yes, I'm from Fairmont, which is at HU Berlin. And I'm also from IKC Berlin, which is a Crystal Growth Institute in Berlin. And yeah, I'm coordinating the area A, which is about synthesis data in the Fairmont project. at IKZ, I'm a data steward, mainly organizing the digital transformation of the whole institute regarding the research data management. And here I just quickly want to summarize what we do within FAIRMAT Area A synthesis to develop a data structure and tools for fair synthesis data. As I said, I'm from FAIRMAT, it's a consortium from the Nationale Forschungsdateninfrastruktur, so a national research data infrastructure in Germany. And our goal is to provide a fair federated data infrastructure for solid state physics and material science. And so here you see an overview of our project. So we deal we deal with different areas. So synthesis, this is where I'm from, experimental data, computational data, and then we have an infrastructure area which builds the tools that we need in our areas. And then we have use cases to really showcase how useful our stuff is. One section is about training and coordination. And so in principle, the area where I'm from in synthesis, we come from in this situation there is that we find a lot of unstructured data. There's hardly no standards. There's no data sharing culture, and also not really good data skills, let's say. So people work with spreadsheets, files are on some file servers, and people document their thoughts in handwritten lab notes. So this is really not fair at all. So all aspects of fair you miss in this approach. And so what we would rather want to have is a database with structured data, which is connected to our file servers where the raw data is. Directly connected, we would have electronic lab notes. So this is to avoid handwritten notes, but at the same time, this lab notes need to be connected to the structured data, to the data models that we have in the database. So at the end, we have machine actionable data or fair data also. So you can then apply machine learning, artificial intelligence tools. So this is like what we are working to. And also we of course want to make the data from the different areas be connected to each other, so that we understand each other when we talk about our different data points, meaning about the same material, for example. And so the good thing is we have already a very good tool, which is the NOMA tool. I think many people of you already know our tool. So it's a web-based software for fair research data management in material science. And it has a background in computational material science. So there it is well established. People use it already in this community, where also the spirit of sharing data is already quite far. And so you can publish data, you can explore the data, you can analyze the data there. And a new feature that we now have is that you can have your local NOMAD oasis. So it's the same functionality as the central public service of NOMAD, but you run this on your own servers. You can highly customize it. You can connect your own data sources or analysis tools. And so, but you can also send then the data from your local repository to the central NOMAD repository. And the key point of the whole NOMAD software is that that it supports structured data. So this works by a schema file. So you define your data, you write the data, the incoming data in a schema file. And by this, and with parsers and ELN functionalities, you get structured data, which is then potentially fair. And so in principle, we strongly follow a bottom-up approach. That means we really develop our tools to the needs of the users. So we go to the users, we directly talk to them and make solutions for them. And this is why we also highly support community standards, which is of key importance also for fair data and sharing the data so that other people can understand. And so what did we do now in our area in synthesis for synthesis data is we so as I said, we use NOMAD as our central tool, and that allows us, whenever we structure data for our users, that we can immediately implement them. So we are really have an established tool that already works, that we just continue refining and improving, but we can directly implement something for the users. So they can directly benefit from working with us, putting effort in defining and structuring their data. And at the same time, what we do is we work on the data modeling, or maybe, yeah, you can also already say maybe ontology. So that's my main point that I want to make now. So we started to develop a data model for synthesis, which also goes beyond on synthesis data. And what we did is we started with like some flexible schemas and base classes that we could use for different users and compose different application definitions. So application definitions is the data structure for a certain synthesis method, for example. And then we continued trying to make references and links between those different data points. And there, the next step was then to define workflow. So getting deeper into data modeling. And at the end, we had like a base class hierarchy, which at the moment looks like this. And we realized, oh, we are not only data modeling anymore, we are working towards an ontology. And the problem here is that we are all more like physicists, like not really people, or we have support from real computer scientists and these people, but we don't have in our team, for example, real specialist ontologies. So this is why I'm here in this workshop, seeing how other people use ontology, how far are they seeing their problems, because I think Hedi made an excellent summary of what the problems are and why there is this gap and missing link here of people structuring data, thinking of fair data, and not getting into an ontology maybe, or being hesitant. And I would agree in all the points that he made. So so this is why I was participating also in this workshop to see what our next steps, what we need to do to bring our data model, or let's say pseudo ontology, to the next level, that people like you also understand how we model our data. Thank you for the opportunity to talk here. You're welcome to connect to me. You can find here our project and the work we've been doing so far.
Thanks a lot, Sebastian. Thank you. So I'm aware we are running late towards coffee, but we had planned to now ask for your input very briefly. So we would like to do another short exercise with you. So we saw what OntoCommons is preparing as a roadmap. We saw what the use cases are around in the real world. So we would like now to ask you a couple of questions. Yes. So again, I would ask you to please go to the menti.com site. So it would be very brief, but it's useful for us. So it's the code is 76766778. Not here anymore. Yes. Good. So I need to access the. Okay. Access the controls. Okay, wait. I'll try without. Okay. Okay, let's do this exercise. Okay, thank you. Because the other day we saw that many of you answered other, so it's easier to ask you what is your professional role. This is just because we might have different participants today from the first day. I just give it a minute for people to connect. Is everybody there? So because then we start with the real questions. I think we have more people online, right? Okay, so first real question is, how is materials data at your institution today? So Maria the other day, yesterday, I mean, she showed we can have open data, linked data, fair data that are 3 different concepts. And so we ask you to please use these sliders to say how is materials data treated at your institution today. So whether it is semantically enriched, so it contains rich metadata or not. Is it human readable or human friendly in the terms of data and metadata? Is it machine readable? And do you have data stewardship in place or not?
What do you mean by?
I would ask Maria to please explain the difference. Yeah, of course, one could ask at which scale, yeah.
Well, that's.
Don't hear you.
No? No? No, it has.
Yes, yes.
Yeah. Okay. It has many lights, but none of them works. Okay. So the Open Data Institute provides the open data definitions and also the Open Knowledge Foundation as well. And actually, they change the definitions from time to time regarding according to whom they want to address. But the opens means data that everyone can use for everything. So everyone, everyone. So if it is for your institution, it's private data. And actually, they have the data spectrum that goes from very private data to open data. And there are different levels for different use cases. So don't think that everyone has to go open. And one thing that is critical for being open is that it has attached a license that allows everyone to reuse that data. Because if you can find data on the internet, that doesn't mean that is open.
To be explicitly open.
That is accessible and you can read it, but that doesn't mean that you can reuse it. So it has to say you can reuse it for everything, even for making business. So having open data doesn't mean that you have to provide open services always.
So let's say for the question by Monica, let's say that we consider that fully open, it means open to all the world. Okay. Otherwise you put open in your institution. Yeah.
Can I also ask, can you hear me? Yeah. Can I also ask a clarification about fair data? Because in this case, if, for example, I have just interoperable data and reusable, let's say, but I'm not following all the principles, should I mean, can I say, for example, the right place, let's say 2, if I'm following 2 of these principles, but not all of them? Or because for me, it is not clear if I should reply only if I'm following all the 4 principles or only one.
So fair doesn't imply open. So you can be fully fair, but no open, because you can have a very close license attached, and that is what fair asks you to have. And you can be open and not fair at all, because you can just provide raw data with an open license, and you are open, but you are not making easy for everyone to reuse and so on, but you allow the reuse.
No, my question was more about the fact that, for example, when you have free data, you need to make them findable, interoperable, accessible, and reusable. But very often, for example, some data can be accessible, reusable, but not interoperable, for example. So for me, I mean, my question was, if someone has fair data, should I consider that all 4 principles are followed? Or if, for example, one institution has just interoperable data, but
to me, the answer is partial.
Okay,
partial, yes. But it could be partial in the sense some of your data. So it's 2 dimensions, like is what amount of your data and how much it is. So it's just a coarse view, let's say. But so we see that we're doing badly. Okay, that's my next take from this slide. And yeah, thank you. So next one is, what digital spaces for materials and manufacturing do you use today already? So we heard about some that already exist. So for sure you use digital marketplaces for other things, but for materials, which ones are you using? So it could be also repositories of materials data, materials modeling. There are many. So we would like to hear. So it's in a broad sense, really. Still few answers. I'll give you some time. I guess in general, we are thinking of spaces that are more or less, I mean, available to a community or available. So we're not thinking, but it could also be, I can imagine if you are in industry, you might also say it's our own international space within the company. I don't know. I mean, that could also be an answer. I can imagine. But mostly, yeah, we were thinking of resources that are accessible, I mean, widely accessible. So let's see. No one, okay. Marketplace, national level, Dataverse, okay, national level. Yeah. Nomad, data lake, okay. SMS. I'll give a bit more time. But I don't see, yeah, I recognize, I mean, between the, okay, Nomad, I recognize between the main ones. Okay. It's also, yeah, Apache and Afuseki, yes. Wouldn't be for me digital space for materials, but yeah, maybe we should discuss what the definition of digital space is. But, I don't know, OpenBIS. If anybody wants to comment on what this is.
It's an ELN.
Okay.
Electronic lab notes.
Okay, so it's like a tool, more a tool than a data space, right?
I think we need to clarify the
data spaces.
Data spaces because
yes, data space. So we should see that. So that there is a definition from the Data Spaces Support Center. And I don't remember it by heart, but we could go there and look for it. But roughly, it's a digital space that has a series of building blocks, like it has, I don't know, APIs in place, and it has a governance and so on and so forth. There are a series of building blocks. But it's more in the direction of database with certain characteristics, more than.
And it takes the overhead of data integration out of.
So
upfront overhead, it takes it out, essentially.
It's something that handles data as APIs, yeah. Okay, so let's move on because in the interest of time. So we would like to ask you, what is your relation to ontologies? So first option is, I do not use ontologies and do not believe in the benefits. I do not use ontologies yet, but would like to use them in the future. I use ontologies to document my data. I use ontologies to facilitate interoperability, and I develop ontologies. Some options are not exclusive to each other, so you can add up to 3, because some can be combined actually. Okay. Let's see where we are. Okay, we have a number of developers. So people people who are answering mostly either develop or use ontologies. And if not, it's like 1/3 that would like to use them in the future. So there is an optimistic feeling. Let's leave just some seconds more. Also, you don't need to follow. When I move slides, you can also stay on the slide if you want to finish answering. Thank you. So in your opinion, so we heard from Hedi some of the barriers and gaps. In your opinion, what are the main barriers to the adoption of ontologies? And this is just to give an idea of the kind of input we would like from you in the roadmap survey. Of course, then we will point you to the full survey, but this is just to give you an idea of the kind of input that we are looking for from the community. This takes a bit more, but okay, so the clear business value is missing, awareness and competence, a lot of manual work, benefits are not clear to industry. So this is one of the points Hedi pointed out before that is important to stress on. Lack of guidelines to develop, fairness missing, not well maintained. Expertise lacking. Large manual effort, this is true. So we need to demonstrate clearly the benefits. It's important to demonstrate actually the usual balance between costs and benefits. This is important to show. Usability. General agreement, yes. Thank you. Okay. Not sure if the tool abandoned me. It's not switching. Okay. Okay. Do you still see the same question? So it means it's not listening to me. Okay. Okay. Maybe it means we need to go for coffee. But in principle, we should be able to go to the other slide, but I guess if two laptops out of two abandon me, I don't know. Yes, thank you. But humans are still useful. Thanks a lot. So can you please rank this industrial ontology needs by relevance? So the first one is collaboration between domain experts and ontologists, combining various domain views and perspectives, having the need of having global standards, the need of meaningful data integration and sharing, and the need of middle-level ontologies to interface between domain ontologies and top-level ones, because we heard of the difficulty of connecting to these very abstract terms. So this is one of the facets of the roadmap. You saw what Hedi showed, that one of the chapters is industrial ontologies and one of the facets are needs. So this is just an example of the questions to give you an idea. So let's see. I guess the ranking will depend a lot also on your experience. So I see meaningful data integration and collaboration between experts and ontologists are considered the most important needs. Not so much the development of middle level ontologies. Thank you. It's in the interest of time. So we have a similar question here, but this is another chapter, is the chapter on infrastructure. So these are the needs in infrastructure terms. So what do you think is most important is secure collaborative tools for multiple stakeholders, inter-organization, having an interactive visualization of data, data quality assurance and analytics, data validation, so infrastructures for this, or trustworthy data repositories and trusted computation. So one is for collaboration, one is for visualization, one is about quality and validation, and one is about trust. So trust looks like the first need, trustworthy repositories and secure collaborative tools. Thank you. We need to speed up, because we're very late. We have the last two questions, if I'm not wrong. So we have been talking a lot about different data spaces and interoperability. The question would be, what is needed next to facilitate interoperability between these different existing data spaces and marketplaces? So we heard, there are efforts along. I don't want to influence you, so I'll shut up. But we heard some solutions, we heard some recommendations. So what do you think is needed next for this specific issue? So some DOM 4.0 is a solution. OSS is also a solution. I see somebody says that this is not important. What's important first is that some are valuable in themselves before connecting to each other. So here, yeah, sorry, we didn't explicitly say, so interoperability, yeah, could be many things. There are many levels. So somebody talks about community building is like at the human level, but I was more thinking of the technical level, but yes, true, we also need that. Effective collaboration, common standards, good mapping tools. This probably is from before, broader understanding. API specification, make sure that they are really fair. I guess these are answers to the previous question, if I'm not wrong. More funding. And then we close with the last question, which is your vision for the future. So after all we talked about, what do you think are the next steps, really what we should do tomorrow as a community to reach materials commons? And with this, then we are allowed coffee. So we heard a lot about what is going on in terms of activities, what are the gaps. But yeah, the question is like what we should do tomorrow more than in 10 years is like what is doable now. So let's see. Some of the answers. Funding is always there. Involve more people, develop awareness, improve documentation, the roadmap. Yes. Imply more scientific societies, so collaboration with already structured associations that are there, so involve with them. Training material, create and offer robust tools that are easily accessible. Partnership, so not only with associations, but also with adjacent disciplines. I guess this is Internet of Things and yeah, materials. Probably more support at the national and European level is needed to, and intervention is needed to push larger companies. So yes, you see, I mean, take it out of academy and into industry. So we see different lines of collaboration is with scientific societies on the academic side, then there is the industrial side, and even more interdisciplinary. Move more into application. And I guess while you keep answering, I would like to thank all the speakers for this session. And I would also like, since at the beginning we were a bit late, to thank the organizers for yesterday for taking nice care of us with the visit and dinner. And I think we can happily move to coffee and thank everybody for your input. Don't forget to follow the link that Hedi shared to really the full survey. So this was just an appetizer. I mean, just a starter of the survey. The full survey is online on OntoCommons website. That was to be in German. Even the site